Weather affects us every day. And really big storms, cyclones, rainfall, and severe weather conditions can be very dangerous. Each year, they cause billions of rupees of damage and put people's lives in danger. We depend on weather forecasts to help us be prepared and stay safe when bad weather hits. Satellites orbiting in space around Earth help scientists forecast when and where storms will happen. Satellite meteorology involves the use of satellites to collect data and analyze weather and climate patterns.
The Satellite Division of IMD was established in 1972.
Satellite Meteorology Division of IMD has been using the satellite data for weather forecasting purposes. We provide the satellite data to our forecasters and the numerical weather prediction centers for their forecasting activities.
History of satellite meteorology in India. Early beginnings. The Indian Space Research Organization ISRO was founded in 1969, setting the stage for India's space exploration and satellite development. INSAT series. The Indian National Satellite System INSAT began with the launch of INSAT 1A in 1982. Although its primary purposes include telecom, broadcasting, search and rescue explorations, INSAT also had meteorological instruments. INSAT 1B, launched in 1983, successfully carried meteorological payloads, included the Very High Resolution Radiometer and the Data Relay Transponder. This marked the beginning of dedicated meteorological satellite applications in India. Subsequent satellites in the INSAT series, such as INSAT 2 and INSAT 3, continued to enhance meteorological capabilities with improved sensors and data collection technologies. Advanced meteorological satellites. Kalpana 1, launched in 2002, was India's first dedicated meteorological satellite, named after the astronaut Kalpana Chawla. It carried the VHRR and provided critical data for weather forecasting. INSAT 3D, launched in 2013, and INSAT 3DR, launched in 2016, significantly advanced meteorological observation capabilities. The recent launch of INSAT 3DS in February 2024 marked the beginning of advanced images, atmospheric parameters, data, search and rescue services. They carried instruments like the multispectral imager and sounder, providing detailed data on atmospheric conditions, sea surface temperatures, and cloud properties.
If I talk about specifically, we were able to detect the fog, thunderstorm, particularly dust storms and other severe weather events.
INSAT series of satellite data is used for location of cyclone over Indian Ocean, Bay of Bengal and Arabian Sea.
Role of satellite meteorology in India. Satellite data is crucial for accurate weather forecasting. It provides real-time information on cloud cover, precipitation, wind patterns and temperature. It also plays a pivotal role in disaster management, like predicting cyclones, floods and drought. Early warning system helps in timely evacuations and preparations, thereby saving lives and reducing damage. The satellite helps in long-term climate monitoring, which is crucial for studying climate change, understanding monsoon patterns, and conduct environmental research. It is also used in agriculture for monitoring crop health, soil moisture levels, and weather conditions. This information helps farmers in making informed decisions. Satellites contribute to study oceanographic parameters such as sea surface temperature, ocean currents, and coastal changes, important for marine navigation, fisheries, and coastal management. India collaborates with international space agencies and meteorological organizations sharing satellite data, which helps in global weather prediction and understanding of climate and environmental changes. Satellite meteorology process. The process starts with satellite launch and deployment. ISRO launches weather satellites that are either geostationary, which orbits the Earth at the equator and provide continuous monitoring of the same region, like the INSET series, or polar orbiting satellite, which moves in a north-south orbit covering the entire Earth as the planet rotates, like the IRS series.
Polar orbiting satellites like OceanSat provide data over the ocean, which is the main source for the data over the ocean because there is no other platform providing data over the Indian Ocean and the Bay of Bengal.
Data acquisition. Satellites are equipped with various instruments to collect meteorological data. Imagers. These capture visible and infrared images of the Earth's surface and atmosphere, helping in cloud cover analysis and surface temperature measurements. Sounders. Measure atmospheric temperature and humidity profiles. Radiometers. These detect radiation emitted or reflected from the Earth, providing information on sea surface temperatures and vegetation cover. Scatterometers. These measure surface wind speed and direction over the ocean. Data transmission and reception. Transmission. Collected data is transmitted to Earth through radio signals. Reception. Ground stations in India receive the data. These stations are part of Indian National Satellite System INSET and Indian Remote Sensing IRS operations. Data processing and analysis. Pre-processing. Raw data is converted into a usable format, corrected for any distortions or errors.
Multi-mission data reception and processing system is a state-of-art technology which IMD has, which processing the data at every 7 minutes.
Analysis. Advanced software tools and algorithms analyze the data.
The image here is the winds-based or the satellite-derived atmospheric motion vectors. So this particular image gives you layer-based information about the satellite-derived winds.
Dissemination of information. The processed data is distributed to various stakeholders, including government agencies, disaster management authorities, agricultural sector, and general public.
We are going to launch INSAT 4 series, which will be the next generation satellites, which will provide high resolution data and will provide atmospheric data profile.
As we move ahead, technological advancement, data integration, and international collaboration will challenge and set the direction for future.
In future, we expect better resolution data, higher accuracy, and improved forecasts.